और था लास्ट क्लास से इलेक्ट्रोमोटिव फोर्स होते हैं ओके उसके बाद I'm just going to write down in the last class we discussed about EMF, terminal potential difference, internal resistance, and relation between all of them. Anybody remembers what is the relation between all of them? What is the relation between all of them? Okay, so if you have any all of you have understood what is the difference between EMF, terminal potential difference, and what voltage drop. There is also something called as voltage drop. This is what it is. Okay, so those who attended the last class, who would like to tell me what is EMF? I will choose someone who will answer. Who would like to answer about what is EMF? Raise your hands. What is it? Yes, electromotive force is the full form. What does it mean? Is it a force? What is it? Is it a potential? Then, when it is not in use, when it is the full potential difference across the terminals of the cell, when the cell is not in use, total energy of the cell. Okay. Then what is V? What is V? Potential difference between the terminals of the cell when it is in use. That is, the current is drawn from the cell. So, the key is open. When the key is open, whatever is the potential difference across the terminals of the cell is E. Okay. Whereas when the key is closed, That means current is drawn from the cell. That time the potential difference reduces and it becomes equal to this. Okay. It is also defined in terms of work done. What you see in the dotted box is the entire cell, right? What you see in the dotted box is entire cell, where small r is the resistance of the cell. Okay. So what is the medium inside the cell? Current is flowing inside the cell through electrolyte. So the medium inside the cell is electrolyte. So small r is the resistance of the electrode. Okay. That's how the conducting path is completed. Right. So this is what it is. So by conservation of energy, total energy. So what is the work done by the cell in taking the charge through full circuit? This circuit is divided into two parts, external and internal. What is the external part? From A to B. Okay. What is the full circuit? From A to A. And what is internal circuit from A to D or B to A? Okay. So work done in total circuit is equal to work done in external circuit plus work done in internal circuit. And this was nothing but QV. This is how we had defined. Okay, this is how we had defined. Total work done is equal to work done in external circuit plus work done in internal circuit. Now when you remove the Q, what do you get? E is equal to E plus 1. Now apply Ohm's law. By Ohm's law, the current is same through both the cell as well as the outside load. So this becomes IR plus IR. This is the expression for current. So when the current will be maximum? When R is 0. Or R equals. When will R be 0? When you short it. Means you join the two terminals of the cell directly. Then it will begin to show spark because there is no load in between. Very large current will flow. This may damage the cell itself. So we never just take the cell and join the terminal directly without connecting some load in. Okay, you have to connect some load. So load is this. It could be a bulb. You can't just join the two terminals of the cell. That means you're torturing the cell. It's like you're just squeezing current out of. वैसा नहीं करते. You have to connect some external load. Okay. Otherwise, cell will burn out very fast and it will be damaged forever. Is that clear? So that's the maximum current possible. So these are some of the expressions which are useful to you. If you can write it in this form as well, E is equal to plus IR or E is equal to 1%. So these three equations are very useful for solving the value. We did till here, I think, in the last class. We did also discuss the factors that affect EMF and internal resistance. Did we discuss that? Okay, let us discuss. Anybody writing or can I erase it? This let's terminal potential difference. Terminal potential difference is the work done in moving a unit positive charge in the external circuit or Alternatively, it is defined as potential difference between the terminals of the cell. Ultimately, terminal potential difference is VAB. Okay, when the cell is in use, when the current is moving, then only. Okay, is that clear? So obviously, V has to be less than U, because when current is zero, V becomes equal to E. When current is non-zero, some of the energy is consumed by cell itself in overcoming resistance to the electrolyte. Some work is lost inside the cell, so that is not available for external work. So the good cell will be the one which has smaller internal resistance. And the ideal cell will have small or equal to zero. So most numericals, wherever they have not mentioned E or V, they are mentioning here V, that means R is zero. Small r is zero. Get it? So many questions. So for ideal cell, small r will be zero. Can I raise it now? Let's go for it. Tell me, what will be the factors that will affect? Yeah. So it is basically the materials of the electrodes, the materials or type of electrode. And type of two cells may be different in the choice of material of electrode and the choice of electrolyte. Okay, that's how two cells from different companies will be either better or inferior. That depends on what kind of materials they have chosen. And there are factors which do not affect EMF. Now, what are these factors? Shape and size of electrode is immediate. Okay. Shape and size of electrode. Then the distance between the electrode. Doesn't depend on the amount of electrolytes. It also does not depend on current drawn from the cell. Okay. So once the cell is manufactured, its EMF is fixed. Okay. So EMF will not change. Till when it will not change? Till the lifetime of the chemical reaction of the electrolyte and electrode. Okay, so there are two things about the chemical reaction that I had told you. One is the equilibrium condition and the other is lifetime. Does anyone remember the equilibrium condition in lifetime of chemical reaction? What is equilibrium condition during a chemical reaction? Let us say, when I initiate a chemical reaction, will it go on forever? No. After certain duration, it will stabilize. So that is equilibrium condition of a chemical reaction. When I again disturb the equilibrium, the reaction will take place again. Okay, subject to the lifetime of the chemical reaction. Like once a reaction has reached the equilibrium state, it will stop reacting. But now when the reaction is the equilibrium condition is disturbed, it will again begin to react, and it will keep reacting till the lifetime. So in cell situation, when the cell is manufactured in the factory, it has reached the equilibrium state, meaning the potential difference is now created between the two terminals. Now you bring the cell at home in equilibrium state with full EMF, right? Now when you are using the cell, let us say to power the light bulb, torch light. So when you begin to glow the torch bulb, the equilibrium is disturbed because the charges from negative terminal begin to flow and neutralize the charges on the positive terminal. The charge on the electrode are depleting due to the flow of current. The moment charges deplete, the equilibrium condition is disturbed. So now the electrolyte, which was dormant, will again react with the electrode and balance the charges again. It will keep replenishing the potential difference. Because the potential difference has to be maintained for the bulb to continuously glow. So this will happen till the lifetime of the chemical reaction. So every combination of the electrolyte and electrode chosen has a lifetime of a reaction. Once the lifetime is over, then what are you supposed to do? If the cell is rechargeable, recharge it or else replace it. So chemical reactions are also of two types, reversible and irreversible. The cell where you have to use and throw is of irreversible type, whereas the cell that you're using in mobile is of reversible type. All of these you have learned. What you've not learned is the role of equilibrium condition and the lifetime of reaction. Maybe you have memorized it as a definition, but the context is not there. Hope this is clear. It will take a while to understand. Once you understand, now future is all electric vehicle and EVs, so it's better that you start understanding how the battery operated devices work and how battery itself works. So what we are learning right now is how battery itself works. All right. So there may be a short answer question on these things. Then one very important characteristics of the cell is internal resistance. This also depends on certain things. What does it depend on? Vector. Yeah. Right. Effect. Internal resistance. Now see, EMF was independent of this. EMF was independent of these two things, but internal resistance depends on this. Okay, so it depends on the surface area of the electrodes. Or depends. How will it depend? If I increase the surface area, what should happen to R? Huh? Increase. What is the relation with the resistance? R is inversely proportional to area. So R will decrease if we increase the area. So R is actually similar relation, just like the big brother. Okay. Then you have what was the other dependency? The length. Length here is distance between the electrodes. The length of the cell. That means electrolyte is spread. Okay. So the distance between the electrode is the length here. So what happens? Anybody else saying? Got it. The competition. It is not given in the volume. It depends on the distance between the electrodes. Then R also depends on the concentration of the electrolyte. R depends on the concentration of the electrolyte. So what should happen if the electrolyte is of higher concentration? Will R be more or less? Huh? R will be more. Why? Explain. Yes, it is correct. So, okay, you mean the mobility of the charges will be restricted. It becomes denser. So the mobility is affected. It is a liquid medium. So if the liquid medium is denser, the mobility is affected. So high concentration means more resistance. Okay. So R depends on the concentration. Concentration. Okay. So R is proportional to C. Okay. There is one more factor. Temperature. Now tell me what happens to the resistance with temperature. Huh? What happens in the conductor? What happens to the resistance of conductor when temperature increases? Resistance decreases there, check. It increases, right? Because the fixed positive ion begins to vibrate more rigorously and therefore affects the movement of the electron, right? So in conductor, when you increase temperature, the resistance increases. But in case of electrolyte, what happens? The concentration will begin to lose. I mean, it will expand, right? So temperature will increase the or decrease the density of the electrolyte. Okay? And therefore, the resistance here will increase. Resistance here will decrease because the mobility is increased. Okay? So R decreases with rise in temperature. So this is a bit of opposite of what happens in the big R. These two are okay. These two are common with the capital R. Temperature is different. Concentration also, there's the difference. So many application-based questions can be framed basis these facts. So keep these things in mind. Many application-based questions might come. Okay, so we are done with the important part of this chapter. Rest from here on is a fun thing. Okay, only understanding part was still easy, right? So, so you have this table provided. Difference between EMF and terminal potential difference. Read through the points. See if you need any clarity. As far as I am concerned, I have already explained. Okay. All the resistors available in the market are of fixed values. Suppose we need a resistance of a different value, right? We can combine the available resistor various forms. The two forms are series and parallel. Okay. So we can then achieve resistance of different values from the available resistance. So let us see how these resistances combine. So when we combine the resistances one after the other, like this. Okay, so this is, let us say, R1, R2, R3. Okay, when they are combined like this, it is called series combination. So each terminal means the end of one device. When one end of the resistor is connected to the one end of the other resistor. Okay, so each resistor is connected with two different resistors. Then that combination is called series combination. This is then connected to a common supply like this. So this kind of a arrangement is called series combination. And here we are writing V. So when we are writing V here, what is the internal resistance? What is the internal resistance here? Zero. V is equal to E because small r is zero. Is current zero? No, current is not zero. So get used to this, okay? You might see here E or V. If it is V, conclusion R is zero. Otherwise, there will be a chota R displayed here. Or it will be written like this. E R. Some values will be given to you. If there is no R and it is written directly V, that means internal resistance is zero. Now, so what are the features of series combination? You see the same current flows through all the resistors. What is the feature of series combination? Same current is flowing through all resistances that are connected in series because there is only one path. So current is nothing but charges in motion. So whatever charge is passing through R1, same amount of charge is passing through R2, R3 because there is only one path. Who is providing this charge? Cells. Okay. So in series, same current flows through each resistor. Okay, this is one feature of series circuit. What about the energy? Will the energy consumed in flowing the same charge through R1 will be same as it is in R2 and R3? No, because opposition is different. So work done to flow the charge will be different in R1, R2 and R3. Least work will be done in R1. If let's say it is smallest, this is bigger, this is bigger. Least work will be done here by the cell and slightly more over here, slightly more over here. So work done per unit charge is nothing but potential difference. Okay. So work done per unit charge in every cell will be different now. Right? But what is the total energy? V. So it is distributed in V1, V2 and V3. Is it clear? So in series combination, same current flows through each resistor. However, the potential difference is distributed on the again, current is same, but potential is divided or distributed. So what are we trying to do? Now we are trying to find out what is the equivalent resistance of this series combination. What? This thing. Like what you did not understand? The first part or the second part? First part should be simple. Current. Current is flowing through this path, right? Is there any other path for the current? No. So whatever current is entering, same current will come here. Current to same here. So that is simple. Then total energy applied is this. This is the total capacity of doing work by the cell. But it is doing different work in different resistances. Let's say this was 10 ohm. This was 20 ohm. This was, let us say, 30 ohm. Okay. So where this cell will have to do more work in R1, R2 or R3? Least will be R1, little more in R2 and maximum in R3. Okay. So that's what it is. So let us say these are the resistors available in market. But I want resistance of value more than all of them. Okay, let us say I want 50 ohm resistance. And 50 ohm resistance is not available in market. What is available is only this. So देखो अभी कैसे आता है वो? So let's say the equivalent of all this is R equivalent. This is R equivalent. If R equivalent is same as the series combination of R1, R2, R3, then current will remain same. Correct? Current is same. So let us find out the relation between R equivalent and R1, R2, R. This is what we want to do. Okay? So this is the equivalent circuit. By this logic, the applied potential difference is distributed among the respective resistors. That is E must be equal to V1 plus V2 plus V3. Isn't it? And now I apply Ohm's law. So by Ohm's law, what is What is D by Ohm's law? I R equivalent. This will be IR1, IR2, IR3. We just applied Ohm's law. Now, by Ohm's law. Okay, so from the equivalent circuit, we get E is equal to IR equivalent. And from the distributed circuit, this one, we get this. E1 has to be, what is the potential difference across the resistance? By Ohm's law, it is the current flowing times the resistance. Is it making sense? Hope everybody knows what is Ohm's law. Right? So Ohm's law is nothing but it gives the potential difference value if the current and resistance are known, just the product. So every resistance में कितना current जा रहा है? I जा रहा है. I into R2, I into R3 वही होगा D. The next step will be what? Oh yeah. So in series combination, the equivalent resistance is just the addition of all the resistors in the series combination. Okay, and it is true for any number of resistors. So therefore, in general, for series combination, is true for any number of resistors. And if you have some n resistors of same value, if let's say this was R, all of them were same, then what will be R equivalent? So many numericals come where the values of resistors are same. That time it will n times R. Okay? Is that clear? This is all about equivalent resistance of a series combination. Okay. So anybody has any question can ask. That is the total potential this time. It is the full capacity, but all full capacity will not be available for outside work, which is what data is. Right? Which cell will be considered better? Not with the high EMF, the one which gives me high P. Because I am interested in P, outside work P voltage. Thing for practical significance for me is P. If the cell is having high EMF, but if it has also high R, small r, then it's really capacity to do outside work is less. Because there is only one path. Whatever charges the cell is pumping in resistance 1, the same charge it is pushing through R2, same to R2. No, that's where it goes extra. R values are different, R1, R2, R3. So to let us say there are only 10 charges pushed into R1 for argument's sake. So it spends less energy pushing 10 charges to R1. But it has to spend more energy for the resistance operator is more. Get it? That's why it is big. Even more energy. But total energy cannot be more than the available energy. Available energy is P. We are using the law of conservation of energy. We actually find out what is the equivalent energy. By using conservation of energy and Ohm's law. Energy here is expressed as what? Energy is W, no? What is B? W by Q. That's what we had at W is equal to. W is total work done equal to 49 total work done. So that textures like this, not we have any. Okay, so conservation of energy gives you this. B equal to V1 plus V2 plus V3. It's actually simple. The first board that I wrote, the first board that I wrote, you should have captured. So reading the way the sequencing book is slightly different. It's not very student friendly. What they have done is they have not maintained the sequence. Out of turn speaking and extra speaking. They have confused you actually. But it is very simple. Not once you get the logic of it. Terminal voltage is always less. Because EMF तो total ability to do work है. कुछ अंदर खुद भी खाया था ना सेल small r. इसलिए तो small r पे voltage drop हो गया वो बाहर available हो गया. E is equal to capital B plus small b है. Capital B capital R में work किया. Small b तो small r में work किया. Small r के तरह सेल के अंदर अलग. बाहर के लिए क्या करता है? B is equal to E minus P. So hope everybody is clear with the series combinations. Let's move on to parallel. what has changed in case of parallel connection? What has changed? Now the potential difference is same across all the resistors. But current is divided. Now see the path. The current that is coming out from the cell is high. But the moment it reaches the first point, let's call this as A and B. At point A, now the current is divided, distributed. So for us, the starting point would be I is equal to I1 plus I2 plus I3. Total current provided has to be equal to the distributed current. Right? If 10 charges came here, let's say 2 went from here, 3 from here, 5 from here, 3 from here, and 2 from here, let us say. Maximum resistance will allow less and less number of charges. So current will be now less. Okay. Now the work done is same, but the number of charges are different. You get it? So this is what it is. Now I apply Ohm's law. So Ohm's law will be equivalent circuit. LHS is for equivalent circuit. So what is this? V by R equivalent. This will be V by R1. What is it? 1 by R equivalent is equal to. So this is how you find the equivalent resistance in case of parallel combination. So I can extend it to a parallel combination of n resistors. So for n resistors in parallel. Okay. So many students make a mistake in writing or expressing the R equivalent. What you have on the right hand side is reciprocal of R equivalent, not R equivalent. So what is final answer? That is R equivalent is equal to 1 divided by 1 by R1 plus 1 by R2 plus 1 by R. This is the final answer. Okay? This is reciprocal of R equivalent. Many mistakes, 90% of the mistakes happen here. What is the parallel combination of this? You actually find 1 by R equivalent and combine. Okay? So, of the answer, you take reciprocal. Okay. Now here again, if further, if R1 is equal to R2 equal to Rn equal to R, let us say. All the resistors are of same value in parallel. Then what it will be? So this will become 1 by R equivalent. Will be n by R. Okay. So if same resistors are connected in parallel, so the total resistance of the circuit actually decreases. Whereas in series, it was n times R. In series, the resistance increases. Okay. So these logics you have to keep in mind. This will help you tackle dividers and judge your answer, whether you have got correct answer or not. You cannot get a smaller value of resistance for a series circuit. ठीक है? Parallel में तुम्हारा आंसर छोटा आना चाहिए. बड़ा है मतलब something is wrong. These are the pointers to judge your calculations. Okay. इसमें there is one shortcut also. Shortcut. Shortcut for two registers in parallel. What is the shortcut? Product by sum. You can take it like you remove, you take the LCM, so that becomes product. And then when you finally take the reciprocal, the final answer will be product by sum. So many numerical will be consisting of only two registers. You don't need to do very lengthy calculation. Just take the product and divide by the sum. Okay. So far we have seen series and product combinations separately, but they can mix the two. There may be situations where you have series combination as well as parallel combinations together, right? So the basics remain same. Go network by network, right? So we'll see that also. Okay, and note. We'll stop this topic with the final note. R equivalent. Have you done numericals of the first unit? They haven't touched numericals. We'll not first completely check the whole check. Then I do the numericals so that those who will be really part will do it along with us. Many of you were not present here. When is the break? So break is expected in 2 minutes. So just to test you, you can find R equivalent between points A and B. We have just learned a little bit yesterday. 1 point. 1.3. No. Yeah. No. So if the answer Have you done this? All of you found RAB. This 2 ohm is in parallel with the series combination. The series combination is added. Its answer is in parallel with 2. Correct? To write this parallel little figure. This 2 parallel 4. Okay. This is how you approach the questions. So what is it? 4 by 3. Somebody said 4 by 3. 4 by 3 is correct. And then you simplify.